Okay, so welcome guys, gals. Well, first of all, I'm a bit sick, so excuse me if I need to cough and because perfect timing. I got sick these days, so yeah, that sucks. But okay. So far we have been building this dogbook project. So, oh, sorry. Okay. So the first thing that you guys started on was basically the architecture, right? There's no secret about it in terms of architecture, but we believe that the one that was presented here is pretty much solid and battle tested. So it's quite good. You know that we have our configuration file separated. We have OI to have everything like hard coded, and we have this like the different. Operations and different ways to connect everything. So I think that's pretty cool. Then after architecture, we start talking about database because on the dark architecture we were playing around only with JSON. So after we restarted the server, everything was lost. So we need to introduce properly databases. In this case, we talk about how to use Postgres. We use it very a lot here in STRV. And how to, because we don't like, personally I don't like to write raw SQL comments, so we use this layer which is called ORM, that in this scenario we use objection. Yeah. And the last thing before this talk was testing, because some people could consider this like an optional time waste. But I think it's very important because the idea is to have like the most robust code base that you could have, and and this is very important when you have like a large group of colleagues that are working on the same code, and the idea is to have it like very battle tested and very robust. So now what? Basically we have everything like solid, robust. We tested. We have our ORM. So, but the things like so far we have been playing around local hosts on local machines. So tonight we're going to actually we want to people use our product. So tonight we're going to start talking about deployments. By the way, my name is Juan Sanchez. I'm a software developer here at STRV. And so let's get started. For agenda for today, we have a small introduction. Then we're going to talk about the different deployment strategies. There are many of them, but we're going to talk a little bit of each of them. Then we're going to talk about a very complicated concept, which is continuous delivery, and also which is it compounds like the continuous integration, continuous deployment. So we're going I'm going to explain like what is all this about, and how to properly understand it. And the last thing is Docker for deployment. On I think the database doc, we use Docker for local development, which is great because we don't have to install locally the PostgreSQL, and not only that, we can use like different Postgres versions and in the same local machine without messing the libraries and dependencies. So we use Docker for that. But now we're going to talk about like the Docker for deployment, how the benefits of using Docker. So introduction. Well, I got this from Wikipedia. The general deployment process consists of several interrelated activities with possible transition between them. These activities can occur on at the producer side or at the consumer side, or basically both. The activities, what it does mean like by producer side, consumer side, is basically the server and the actual workstation that is making the push to the changes to be deployed. So basically, let's talk about software development. The goal of all of this is to make our software to be used by clients or by end users. That's basically the goal of this. And basically it consists in different activities. One of them, I would say like the most important one is pull or push from your version control system, which could be Git. So you can configure like webhooks to push your code when something is changed, or you can basically clone the stuff with like a script or just manually. That's basically the most important part. After that, sometimes the code is not ready to be used because you got this from a raw repository. Sometimes you need to compile it, build artifacts, or basically you can update the dependencies. Sometimes if your code does, sometimes you need to only update dependency, even if your code didn't change, and that's considered another deployment, so that's very important. And not only that, when we build our stuff, we compile and put the thing running, we need to check that everything is running well, because otherwise we need to start with a rollback process, because we need to always keep our system healthy, always responsive, even with the new deployment fail. So that's very important. We need to check our health status. And the last thing is specify the release versions. We always need to tag our versions, so we can, by the way, we can tell our clients, our end customer, like, okay, we're running on the version 2, this is a pre-alpha, this is like a beta version, and this is very important to keep everything in order. And I think it plays along with the health status, because we can, for example, if we deploy a major version from version 1 to version 2, and something very bad happened, we know that version 1 has been tested for a long time, and we can roll back easily. Very often we use different environments for deployment. That usually are three, that are development, pre-production or staging, and production environment, which is the final and where our real clients go on. So let's talk about deployment strategies. Basically, there are two deployment strategies. The first one is on-premise data centers. This is the old way to do it. Like, okay, you build, you buy your own infrastructure, your own like a networking system, your stacks, your routers, your everything. So the things that you need to take care of all the hardware, networking, and maintenance. So this is one way to do it. You need to take care about upgrading obsolete parts. Well, of course, like some cables could get like messy, or I don't know, some racks. Okay, this rack is just burned out, so I need to replace it. So this kind of stuff. And actually, there should be a good reason to go this way, because probably you have, of course, right now we use like it's cloud deployment strategy, but the on-premise data center is not a bad way. You should there should be like a good reason. For example, like you're running some government stuff, and you need to have your own your database in a specific place. You can some license stuff. For example, you're saving credit cards stuff. So it's better to have it in your own data centers. So there should be a good reason. But the second one is just cloud. Cloud is an infrastructure which is ready, provisioning all the hardware, software, and all the configuration to be ready to be used. There are different cloud models. I will speak about that a bit later. So the thing with cloud is like many providers, they give us like different kind of service with different models, which we can like pay by on demand, or you can like reserve some resources, or yeah, there are many different models. I will explain a bit later. As I mentioned, different pay models, and there are many providers. So which are the cloud models that we have so far? The first one is infrastructure as service. This is like the let's say like the first layer of abstraction that a cloud provider can give us. For example, this basically consists like this cloud provider has all that networking ready, like the service ready to be provisioned, and all the basic security. Like for example, like they have like a proper firewall. They have like the proper mechanism to replace obsolete parts. So this is like the first layer. This means like this layer it consists of more configuration for our part, but still we don't have to buy anything and take care of the obsolete parts. So the cloud providers on this layer, of course, are AWS, Azure, Google Cloud, DigitalOcean. There are a lot more, but I think these are the more important right now. There we have another layer of abstraction, which is called platform as a service. Basically, this is built on top of the infrastructure, but the thing is like we only care about like the actual application, how it's configured, and how we can like manage like the environment variables, all this kind of stuff. And the thing is like, okay, for example, with the infrastructure as service, we need to take care about like the. 'Cause, 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 the operating system. We need to patch the operating system, update the dependency. Like, okay, there's a security breach, so we need to update this. So it's like you need to have like a team or someone that cares about this. But in the platform as a service, you only care about like your application environment. So it's very cool. But as this is a new abstraction layer, you have less flexibility and you need to pay more usually. And platform as a service, of course, we have Heroku, we have AWS Beanstalk, and lately we have AWS Fargate, which is very cool in Docker. And then we have software as a service. This is basically software ready to be used. There's no flexibility at all. It's just, okay, you have this software and it works like this, and you decide to use it or not. We have Dropbox, for example, Slack for corporate messaging, and Google Apps, the whole suite of Google Docs, Google Sheet, and Google. Sorry. And the last one is serverless. Probably you have heard of this. And there are two models that are grouping on serverless. We have the first one, which is function as a service, which we have basically AWS Lambda, Google Cloud Function, and functions as a service are basically like this. Like I would say like the absolute abstraction layer on cloud solutions, because you only you only need to write code, basically that, and different, and you only, you need to write code and configure how you trigger this code, basically that. You don't care about like which dependency I'm using, like, or with the operating system at all, or like how we migrate, how we isolate, because most of the, I would say like all the function as a service solution, they scale out very like automatically. You don't need to care about it, so that's very great. And then we have like backend as a service, and I think that the greatest example is Firebase. I don't know if you remember some old backend as a service called Parse, but they made it very bad. That's why I didn't put it here. But Firebase, I think, is the greatest backend as a service that we have so far. So yeah, that's all the cloud models. So yeah, let's start talking about Heroku, because there are many. As you can see, there are many cloud models. I think that the previous slide could be like a different, I would say, like Cloud Nights event that we start talking about all different ways to achieve deployment on the cloud. But for this Node.js night, I decided to use Heroku because it's the, I would say, like it's a platform as a service. We have we don't care about like the operating system, all this stuff. We just deploy our app and it works. So best choice that we have. So yeah, it's a very popular platform as a service. One important thing, Heroku is on top of AWS, so you can consider Heroku like a software, let's say that, a big software layer on top of AWS. Of course, there we have like this software layer, we need to pay more. If you could achieve the same thing on AWS as Heroku, but you need to update your stuff, and you need you could pay less. But the thing is, like, this is like the change that you need to make. So let's talk about like a high-level architecture of Heroku. The first thing are called dynos. Dynos are basically, you can think of Docker. Dynos are basically containers that we deploy in our application, and this container could be replicated, and we can scale our application. So basically, that's that dyno. Then we have the stacks. The stacks are like let's say like an application. The operating system that I'm running on top, below your dynos. Heroku only use Ubuntu, but you know the Ubuntu updates, so they need to update their Ubuntu, and they call it stacks. Basically, that's what it is. And the last thing is called add-ons, which are basically everything else that you can plug on your application. There could be databases. You could be like it could be like a log application, like manage your logs. It could be many things. There are many add-ons. Also Redis, for example. Everything that is not on your application, it could be an add-on. And sometimes it costs money, of course. So yeah. And one important thing I forgot to mention about dynos is like there are basically two kind of dynos, which are the web dyno and the worker dyno. The web dyno is basically an application that is ready to receive requests from HTTP. So that's basically what we want right now. And the worker is something I will leave it for the next talk, basically the next week. So yeah, that's something important. One important thing about Heroku, a cool thing is like we can use just Git to deploy stuff. So it's very great. Okay, I think it's too much talking. Let's just start configuring the stuff with Heroku. Okay, so here is our application. I just created this new branch, but it has nothing. I have here, for example, it's basically a clone of master. It's the same as you can have. So the first thing we need to do, do you guys, well, for those that are following the steps, you guys install Heroku CLI? For example, you could be able to run this. So the first thing we need to do is, like, since this work on, to make deployment with Heroku, we need to be logged in to be able to push the stuff through it. So that's the first thing we need to do. So we just log in, click this, we made this command, choose your email, and then you put your password. Oops, wait. And yeah, with this, you're able to push your code to Heroku through Git, of course. So that's very cool. Okay, so now before doing stuff here in the code, we need to create the application itself. It could be done like through the console, but I think it's better to have it like to check it here because there are like it's more variables and we can see what's going on. So we hit here this this corner over here. We click a new create a new app. It's very it's logging again. Okay, so we click here, create a new app. I would call it Nodejs Nights Heroku. One thing, the names are global. So if you try to write this, probably it won't work. Of course, Europe, because I want to have it.
Who's that?
Yeah. And for example, this part over here, like add to pipeline. Sometimes you can have like a pipeline is basically a group of application, and sometimes this is useful because you can have like different environments. As I mentioned before, that you can have like a development, pre-production, and production environment. So the idea is to group all of these in the same pipeline. So that's very cool. So yeah, our application is ready here. Well, the container, I would say. Basically, what we need to be able to run our application is create a file called prop file. Probably people that have already played with Heroku will know about this. And it basically, as I mentioned before, the profile defines which kind of dyno we want to run. So for example, as we work, this is a web API, we want this to be a web worker. So basically we just specify like, okay, this is a web column, and then we need to put the column that we have to run after that. So basically we can just use this, the node app and the source app.js, which is basically what we need to run. And there's another stuff which is called release, which is like a placeholder that we use to run a command that is always that is needed to make a proper release. So for example, the web, this specifies what I need to run our web dyno, and the release is just a command that we need to basically to make our dyno ready. So in this scenario, the only thing that we need to make to be able to run our application is to migrate our database. Do you remember that we have this this command over here, like this command over here, which basically takes all the migration files. It reads the next file over here and it starts doing the migration. So this is the thing that we need to make. So this is basically, we can consider it like our release. So basically we just npm that. So basically, I think this should be like this. And then we need our database because, for example, so far we have our local database over here on Docker Compose, but we not going to use that on the Heroku environment. We need to add a proper add-on. So we go to resources. We go here to this part of add-ons. Basically, click here. You will open basically a market of add-ons. There are a lot of add-ons and different categories. So we just go for the Heroku Postgres, which is like the default Postgres integration for Heroku. One thing, this is the first, like the hobby. They have different plans, and of course we're using everything which is free, but of course not ready for production. But yeah, for example, it's pretty great. So here, okay, we need to choose the plan. Of course, the free version, and we need to choose the application, which is Nodejs in my case. So provision add-on, and that's it. Basically, with this, that's the magic of a platform as a service cloud solution, which basically we don't have to even use Docker or whatever. You use, okay, click here, click there, and we have our database ready. So the thing is, like, for example, if we go to settings. We can reveal this section over here, which is like the environment file that are going to be used for this application. And since we add an add-on, we already have all the Postgre URL ready to be used for the database. So it's very great because we don't have to look at the credential. The stuff is made automatically, and the name is pretty great because it's exactly what we use on the application. I don't know if you remember. We go to source config index, I guess, no, default. You can see here that, for example, the environment variables that this application use are port, out secret, and database URL. So this is already set. So this means like if this variable is set, it will use it instead of the default one. So that's great. The out secret, we can leave it, or yeah, we can make a different. Blah 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 blah, whatever. And the port is very tricky. This you can just ignore it because the port is being managed by Heroku. It will put the port that is more convenient on their side, because the one thing about Heroku about their free dynos is like everything, all the dynos are running on, let's say, on the same computer. So the thing is like they play around with this port and they have many dynos running from different people in the same environment. But the thing is that you don't see that part of like it's isolated but not so much. So yeah, so the port you don't basically, if you can just put it here, but it will just ignore it, put the port that is required. I think that's pretty much it. So yeah, let's make the first deployment. I think this is okay. To make a deployment is very easy. We can just go here. We already are logged in. We already have a Git repository, but we need to add a Git remote because everything works with Git. So we click this this command, and you can see that now if we run remote -v, we can see that we have our origin, which is the original repository for the Nodejs Nights, and the Heroku one. So now we just need to push the stuff to the master. That's one important thing. Okay, so okay, the thing is like we want just to deploy this branch. Wait, we first need to commit this status. Let's add this commit. We'll call it init Heroku. So that's pretty much it. So now we can just hit there, but we need to, well, I need to deploy only this branch because by default it will deploy the master branch. So, which is I'm making like I'm telling Heroku like, okay, deploy this deployment branch to the master branch on the remote repository. So it should be like this. So here you can see what's going on inside. As you can see, it will run the environment production by default. This is like the pre-default environments, like node reports false, that you want to catch all the node modes. That's great. And yeah, it will start. It will show you, and probably this will fail. And I don't know if you guys know why it will fail. Just because this, well, it will start building and stuff. But because this environment variable, this will fail. I forgot to do something. You notice? No? We go to config, and the environment that we have so far are local and test. We don't have a one called production. So this will fail because the node environment is attached to that part, I think. Yeah, you can see here. We get the environment from the node M, which is being set here. By default, is local. Great. But the thing is, like, it will try to get this file, which is M from an environment that is set. So we don't have production one, so I forgot to do that. Yeah, so let's do it very quickly. And yeah, it could be whatever. Just it needs the file. So far, I don't need anything here, but probably would fail. Yeah, we can check it here. Activity. Yeah, it failed. We can check the logs. And it failed because another stuff. But the thing is, like, this production was needed at all. It could be an empty file, just exporting an empty file, because I don't have anything like very important to change on production. The only stuff that we need to set are set by the environment variables that are here. So the default will apply, and that's great. But the thing failed also because the npm, I missed the wrong sentence, because by default npm it knows what is npm start, but if you put a different name like this, it won't work, because by default you have a star, test, whatever, but pre-default scripts you need to put wrong. So I think, yeah. So let's fix this. Fix Heroku. And then we can just push again. And with this, we should have our first deployment. So
all the production.js file again, please.
Here. Let me search. The thing is, like, we don't need anything here because there's no for example, here in the test environment we need the host name to be localhost, the logger needs to be disabled, all this stuff, and the connection will be like localhost. But all this stuff are set on the default. For example, the database is being set by the environment variable, and I don't need to like repeat that configuration here. So that's all I need. So okay, build succeed. Done. Let's check. Launching. We can check here. It's been deployed. You can see the logs, and you can see like it run db migrate, database, It run the 2 migrations, and it should be done, right? Yeah. So yeah, it's deployed. Everything is working. So we now go to settings to see if that's correct. We go to our domains and certificates. These are the default endpoint that the Heroku exposed for our application. So we go there and we go to, I don't know, Postman. And yeah, let's, not found. Okay, so there's, I don't remember, I think it was users. Let me check quickly. Oh,
let's, yeah, users. So yeah, let's check this out. Row, JSON, name, one, email, and password. It's created. So we have our access tokens, and we are hitting the recently deployed stuff. So we achieved that. That's great. Any question so far? No? Okay. So far that's great, but this we need to just hit the command to to deploy our stuff, and yeah, it works great. But the thing is, like, we like to automate everything, so we can just improve this with something called continuous delivery. So what's continuous delivery? First of all, there are many authors that explain this very different. So I will explain it how I believe is the correct way to do it. So probably you have read about some articles that explain, oh, this is this, and continuous integration is this, and they're excluding and whatever. But I will explain how I believe it works. So if you have any question after the talk, we can discuss and to see. And well, basically, continuous delivery is a brief concept. It's a process that consists on keep your application at delivery ready state. A delivery ready state is like, it's just not like, oh, you're deploying automatically, but you're deploying a correct stuff. Like the delivery is correct. Like the application is being tested and like being reviewed, and yeah, it's ready to deliver. The continuous delivery comes along with automation strategies and different services. It depends of the application, but for this one, it could be very simple. We just need to test our application, and after that, we just deploy it to Heroku. It will be very simple. So we have what I believe is like continuous integration is one of the part of continuous delivery, which consists on build or compile your application, and that compilation succeed, and after that the test succeed. If you don't achieve this, you can say like the integration of your new changes is not possible. That's the name integration, because the idea to have a continuous integration that you have your code ready to be integrated to the main branch, let's call it like that. So that's how I perceive it. And then we have another important part of continuous delivery, which is actually deploy the stuff. So basically, continuous deployment is the part of that we have a script, a service that actually makes the deployment. In this scenario, we can call it like some script that basically hit the git commit to git push to the master branch on Heroku. That will be basically the script that we're looking for. So if you achieve these two, you are achieving continuous delivery. That's basically it. So what are the common steps for continuous delivery? Of course, start with committing and pushing your new changes to the code base. Then this continuous delivery service, we call it scripts, whatever, fetch the dependencies for these new changes. It compiles or build, depends. For example, for our project, it's not needed at all. But for example, if you have TypeScript, you need to compile the code base. If you have something like, I don't know, like an Android application, you need to actually build the application. So this is like an important step. And after that you compile and your build is ready, you need to test and check the coverage. Test is already something that we have. And the coverage is basically okay that our tests cover most of the code that we have. After that, we need to package the application. This could mean like, okay, we're building some artifacts, some like, I don't know, something like an image, something like represents that our new build is being updated. For example, I would say like, yeah, in Android could be like building the actual API that we want to deliver to the client or something like that. And actually, then we deploy and release. That's basically it. So we have also, sorry, after this, we have like what will be included on the continuous integration. Oh, so we have the same basically the same basic steps, but we just forget of the part of package application and deploy and release. That's basically what the continuous deployment take care of. So basically, if you can have just a continuous integration, which consists of these 4 steps, and this is important because, for example, when we're building new updates on our application, we usually open like a pull request, and we don't usually want to deploy the pull request itself. You just want to get to this step, which actually we test the stuff, and we know that our code compiles correctly. We don't want to deploy. It could happen like you can have like a ephemeral deployment status per pull request. That would be great, but usually you just go to this step and that's it. You have a great continuous integration pipeline. So let's talk about continuous delivery services that are there. The first one is Jenkins CI. I would say like this is like the father of all of this. It's open source. It's very old, very robust, built on Java, and yeah, it works well. But the thing is like, of course, it's open source. You can grab the dependency, build on your machine or the workstation that you want, and you need to configure a lot of stuff. So it works, but you know you need to configure many stuff. Then we have drone.io, which is basically, I would say, like a fresh concept of Jenkins. It's also open source, and it automatically works with Docker. It will basically spawn Docker's containers to build your application there, and then it releases, and yeah, that's how drone works. It's pretty great. Sorry. Okay, then we have Circle CI, which is not open source and is the first paid service. It's very great, and of course, you don't have to configure many stuff. It's just like they provide like a small configuration file that you need to put like different steps that you need to accomplish to make your continuous delivery pipeline, and that's it. We also have co-build a code pipeline. This is from AWS. They work great, but I think they need to. Secret CI is way better than this. And the last one, we have Travis CI. That's the one that we're going to use tonight. And it's pretty similar to SQL CI. And yeah, I think that's pretty much it. So let's talk about Travis CI a little bit. As I mentioned before, for SQL CI, all the configuration is made by a configuration file. And for Travis, it's made via this travis.yaml file. You can have different build environments. You can specify, okay, I want to build on top of Ubuntu. You can specify which version, trust you say not precise. You can also build on Windows Server or OS X. And basically, you can have different configurable build steps, which basically are like the install part, which is only for installing dependencies. Then we have like a pre-script that, I don't know, you need to fetch some file or whatever. Then we have the actual script, the test part, which you can put all the tests, run all the tests and check that everything is correct. And then you have like after succeed, like, okay, everything succeeds, so now what? Which usually you can use this step for upload the code coverage to a service and check like having like, okay, a continuous checking that, oh, I'm improving my code coverage or I'm degrading the, so yeah. And after that, you have the deploy step, which basically is where you specify the deployment. And yeah, it integrates very well with different cloud providers. Of course, Heroku is one of them. I will show you. So yeah, let's set up Travis CI. But first, I need a little bit of water. Okay, so Okay, so so far we have our Heroku configure. Our profile will work well. This, I think, yeah, we don't have to change this. We actually need to set up the Travis YAML file. So yeah, let's just create it. .travis YAML file. Yeah. You need to call it like this because otherwise Travis won't know what's going on there and won't basically trigger anything. And one important thing that I already have configured, and you probably need to, is to go to travisci.com and configure the application to be like yeah, like to let Travis know that you want to start building your application with yeah, to start the continuous delivery pipeline with Travis. So for example, I already did it for Nodejs nights. I was playing around, of course, preparing everything before talking to you. But you need to do this, and of course, Travis is a paid service. But if you have open source repository, it will be completely free. So I believe you all of you guys has this on public repository, so it won't charge you anything. So the thing is, like, you need to go to for example, here I go to my personal account and I choose. You should see like all your repository here and just hit settings and it will basically attach it to the Travis CI. But it won't be begin any build because we need to set up the Travis YAML file. But this is needed because otherwise Travis will just ignore the stuff. Okay. So if you have any question on this part. I cannot show you because I already did it. So yeah.
You just allow Travis CI access to your GitHub account.
Yeah, right? Exactly. You can put like only this repository or scan your whole account. It depends. Yeah. So yeah. Okay. So let's configure our Travis YAML file. Well, I have it already here because I could forgot something. I will explain every step I have prepared here. So the first thing is like, well, it's very obvious. We're requiring sudo privileges to the machine that we're starting using for Travis. As I mentioned before, by default you use Ubuntu. I'm telling, okay, I want to use trusty environment. This is basically, okay, we want to build a Node.js application. This means like everything, like I don't know if you guys use NVM, which is Node Version Manager. Well, basically this is telling me, okay, have NVM already there installed. And this is basically telling you, okay, which NVM version you will use. So that's pretty much it. The branches is very important. This is optional, but this means like only master branch and pull requests that want to be merged to master branch will trigger Travis CI. So it depends what you want to build. For example, if you have different environments, this could be something like develop and staging. Yeah, this is very like common. So of course you have your pull request hitting develop, and then you start merging stuff, and yeah. But for this scenario, we don't have different environments. We just need master. This is important. It's optional as well, but is the speed up your builds is basically telling you, okay, I want to catch our node modus. That's obvious because node modus is it could get so big. So yeah, it's better to have it catch. Services. Here you can have different kind of services. I think you can have like Java stuff, but so far we just need Docker. And why do we need it? Because we are actually going to use the Docker Compose file on the Travis pipeline. Here we can set up global environment variables. So far we just need test. So when setting this, we know that our application will read this file. So that's great. Sorry. So here is the different build pipeline steps that I mentioned before, which are like the install before script after success, all this stuff. So install, as I mentioned, is just to install the dependencies that you need to make this happen. Like in this scenario, you just npm install. For example, you need like a different, I don't know, a binary file, I don't know, like a different dependency that is not easily found on Docker. For example, FFmpeg, which for video management you need to install it separately. So this will be the step to install it. The before script, okay, this is very tricky. The first step is because Travis by default it has a PostgreSQL instance running, and yeah, basically I'm telling it like to stop it because I want to run our default Docker Compose Postgres. Why this? Because I don't know exactly which version of Postgres it is, and I want to keep it like the same environment that I'm trying to, for example, in the local machine, I want to achieve the same environment on the Travis, so that's why I need to run it on infra, our own infrastructure. This sleep is very tricky because the next script is to migrate the database, but if we run this, the database could take a bit time to set up. So we need to sleep a bit the console because otherwise the database won't be provisioned, so it will fail. Then the script, well, actually the actual test that we need to run the test. And after succeed, this is just a mock that, oh, we're loading our code coverage to some service, and this will be part of the homework, so that's why I left it here. So yeah, notification, this is optional because by default, Travis sends you a notification that everything goes well, goes wrong, so yeah, it's very spammy. And the last part is the deployment part. And you can go to Travis CI, the docs. As I mentioned before, Travis, Circle CI, yeah, all these ready-to-use CI environments are very well integrated with cloud providers. So we can go to deployments and below, and you can see this huge list. Like you can deploy like basically everywhere, and not only to compute engines. So you can also deploy some artifact to S3, for example, and yeah, you can make so many stuff. So Heroku is one of them, of course, and yeah, I will explain it here. Of course, you need to specify deploy. The deployer is Heroku. Skip cleanup. Well, this is actually optional, but this means like, for example, if you're making some artifacts and stuff, when it reach the deploy step, it will clean up everything that is not initialized in the, I mean, like it's not original cloned from the GitHub repository. So for example, you have like a TypeScript project and you compile it during the pipeline. You want to deploy already because you don't want to compile everything again. So you skip that cleanup and upload whatever you have. So, but this is optional in our case. The API key, this is, I will explain right now. The app, this is very important. We just need to match the application that we created on the Heroku. I think I name it differently right now. This was when I was playing by myself. But here, you can see this is the name. So we go here, we set up the proper name, otherwise it won't work. The strategy is Git. We use like the local workstation. So, and here we can set up like which branch we want to deploy. This is as well. You remember with Heroku we could have like a pipelines, which is a group of application. We have a development application, staging, production. So we can specify here like, okay, deploy the master to this one, deploy the development to this other. So yeah, so we can play around with this, but we only want to play master. And the repository, this is as well very important. This is like, yeah, to make everything match, because otherwise, for example, if you have, this is to prevent, for example, when you have an open source code and you have people, you know, you're famous, you have a lot of stars and people forking your stuff, and people actually can use the Travis pipeline, but the thing is like the fork will of course be different. The GitHub repository will actually be different. This is like to avoid to people deploy to your own application. So this is very important. Here, the API key is, of course, very, very important. This is basically like the Heroku login that we need to make. But the thing is, like, we need to make it with a key that we need to generate. We can go to the documentation, and to make it is just like this. Oh, I forgot to tell you guys to install Travis CLI. I just noticed, but it's not. I think you can do it by brew, but yeah. So here with this command, you can, yeah, basically it will run, it will encrypt whatever this command returns, which is Heroku out token, which is like a small token, but we want to encrypt it because, as I mentioned, this is an open source. This is a this is a public repository, so we cannot just put our raw key here, so people can just use it to do bad things. So you can grab this, we can copy it, so yeah, it's here. So now it's pretty much done, I think. But actually, as I mentioned, we just with the branch stuff, is like, okay, when we want to deploy our final, to keep our production environment. But so far we are playing around with this branch. Probably you guys are playing with the master, I don't know, but for this demo I need to change this because I want to show you how Travis works. So basically I'm telling, like, okay, let's play only with this branch because I don't want to merge it right now. I will merge it after all the lesson when I deploy all the stuff. So yeah, this should be enough. So we add the Travis commit init Travis, and it should be like that. So yeah, we go here and we push this to our repository. Okay, so we can just go here. This is the repository. We go to branches, and there you go. This is just the first build I made it. This is when I was testing everything, but this is the new build. So here you can see like the name of the commit, the total builds that you have been doing with this repository, and yeah, everything, like all the metadata of the commit itself, the node version. You can see the configuration here. Well, it's translated to JSON, but it's the same file. As you can see, well, it contains Linux, trusty, sudo required, whatever. But this is the same YAML file configuration. So yeah, we need to wait a little bit, but it should start soon. Yeah, there we go. So with this, we should be able to, we go to overview here. Let me move this. Okay. So it's cloning everything. It's using NVM, installing the version that we need, setting up the build cache, but there's nothing, of course.
Will you show the key that we encrypted?
No, the thing is, like, this key is unique for me.
No, like I generated it and it says like token will expire someday, but should I like output it somehow?
But what do you mean, like which token?
Also, it's only Travis encrypt, and then that thing without the dash add deploy the API key.
This is to tell Travis to include it automatically, but I don't like to use that kind of thing because it will like modify the whole file and put it like everything without space, and yeah, I think it's very hard to read after that.
Okay.
Yeah, there's some like ads. Yeah, some configuration to make to ask Travis to put it automatically, but I don't like it.
And where does it put it?
Here in the deploy.
Oh.
So you have API key, then you create this secure a namespace, and you basically paste the whole key there. So let's check this. As you can see, well, let's go install everything. I need to show you this. It stopped the Postgres on Postgres. It run the infrastructure, which is downloading the Postgres Docker file that we have in our infrastructure, the Docker Compose file, and then we sleep 5 seconds. This is needed because otherwise this migration will fail because the database is not ready and not, it's not immediately.
Is there a more reliable method than just waiting a specific amount of time? Can you actually like listen, process it, or is this the common practice? Just sleeping?
I don't.
Sleeping.
Sometimes you sleep then.
Oh, okay.
Yeah. Yeah, it really depends. Well, or for example, if you.
Facebook day sleeps 1,000.
Yeah, so for example, here is because I'm running the Docker Compose up just before the infrastructure.
Yeah.
The migration. But it depends. For example, you can play around and put other commands that you need to.
Okay.
Yeah.
But I mean, the common practice is just to sleep. There's
Yeah,
no
you
like,
need to wait some time.
There's no like, hey, actually get a confirmation that this process is up and running.
Yeah, it's better to use sleep. Yeah,
Okay,
you can. Yeah, actually you can do that, but that will be tricky. Okay, so here we just run the test colon coverage. So here our docs test. After that, the coverage. And here we are uploading our code coverage, and after that, yeah, everything is deployed. It seems so. So yeah, I think it's this one. Yeah, 7:30 p.m. Yeah, it's this one. So everything is deployed. You can check the logs. Yeah, the logs. Well, it will run the migrate, but there's no migration changes, so everything is okay. And yeah, so yeah, I think that's pretty much it. The part of the Heroku deployment with Travis CI. So yeah, let's make a break.
Cool.
Okay, and then we continue with the Docker part. Okay, guys. Now let's go for Docker for deployment. So let's start. So let's start with a recap because, of course, you heard about this on the databases talk. But yeah, it's always good to have a recap. So yeah, basically the Docker is a container-based virtualization solution. I would say like the most famous one, of course. There are a couple more, but yeah, this Docker is the way. And basically, the benefits of this is like if you compare a normal virtualization with container-based virtualization, the biggest benefit is like we have the replication of operating system kernels. Because, for example, if you have like a computer and you have like 3 virtual machines, you will have. Imagine like you have 3 virtual machines of the same Ubuntu. You will have the same the kernel replicated on these 3 virtual machine, and that's a waste because the kernel is the same. We don't need to care about like. It will be great to replicate it, and that's what Docker does basically. And instead of having like a complete virtualization, you just have this layer, which is actually the Docker engine, and on top of that, we basically put the named containers, which are basically using the same kernel and just isolating whatever you have on there. So with Docker, you only care about apps and its directly dependencies. That's great. And it's very great for portability because Docker engine it contains like a versioning, but if you have different workstation with the same Docker version, or well, I would say that the same Docker, it should be like very easy to move one container to another Docker engine, so it will work right away. And it's very, very easy to scale out because you have Dockers, you can think of Lego pieces, and you can just replicate these Lego pieces and scale out that on the edge. So yeah, that's very great. And also you have runtime isolation, as I mentioned before. For example, for the Postgres, we can have like different Postgres versions, the version 9, the version 10, and on the same machine without dependencies
colliding each other, so that's very great. The same for an application. For example, we can have 3 Docker containers with the same code base, but one running Node 7, another run 8, and the last one with Node 11, which is the latest version of Node. So that's very great. So let's talk about some important concepts of Docker. Basically, the first important concept is images. It's basically a written place which we use to create, or what Docker used to create containers. It's composed of layers of other images. It's like just a progressive construction, I would say. So basically, the entry point of Docker image is just called scratch. The image is called scratch, and on top of that you can build whatever you want. And every time you put a new, let's say, a Docker file command, it will create a new image, a new layer, and that's how it works. All the images are stored in a registry, like Docker Hub. Docker Hub is the public one, or the free one, so you can push all your images. So by default, whenever you want to, for example, get some Docker image, it will by default go to Docker Hub. If you have your own registry, or for example you're using ECR, which is like the registry for Amazon Web Services, you need to log in because it's private and you have, I don't know, your private stuff there. But for open source, Docker Hub is a great solution. Then we have containers. Basically, you can have the analogy like if an image is a class, then the instance of this class will be a container. Basically, it's like a running image, basically. So yeah, it's a runtime object. It's lightweight and portable. As I mentioned, it's supposed to be lightweight. You can have very, very big containers, but the idea of Docker is to have little pieces and then match them together somehow via networking or a queue, whatever. And then the last concept is the registry. As I mentioned on the image part, is where you store your images, and all as a Git repository is stored via the tags. That it could be like an analogy of the commit ID. So every image has its own tag. So now let's start talking about Dockerfile, which is basically the file that we use to define an image. So it's the way to define a Docker image, she's mentioned. And it consists of different commands. It contains many commands, but there are some optional and others that are not. So the first and the most important one is the from command, which is like from which image I will start building this new image. So as I mentioned before, the default image is the scratch one. So if you want to be like a empty, like with no dependency at all image, you use from scratch. But that you need to have a very good reason to that, because there are many, like there are containers for everything right now. So yeah, but you can do that. But in our scenario, we use basically from Node, because that we will get ready. An image ready with Node installed, and we just want to use Node, and that's it. We just want, okay, I have Node installed in this container, I want to use the command, and that's it. Then we have workdir. This is basically to specify which work directory we want to work on in the container. And it's basically, you can think of a combination between makedir and cd commands. You basically tell, okay, I want to move to the /app directory. If it doesn't exist, it will create it, and then it will move it. And if it exists, it will just move it to that directory. Then we have the run. It basically is like well, it depends of which image are you coming from. Which, for example, you're building an image from Ubuntu. The run will basically match bash, like a command line interface. Here you can use commands as you can use whatever you can use here. And yeah, it depends on which image are you building from. Then we have the copy and /add. Those will work pretty much similar. Basically, you can copy from your local host to the container on build runtime. So for example, you need, in our case, of course, the thing that we need to copy is the code base itself, because we will have our Nodejs image, but we need to copy our code base. And the difference between these two is like the copy is only works for the local host copy stuff, to copy stuff only for the local host, and then the add is like the same as copy, but also could fetch data from internet. So you can put some URL and it will fetch it. So that's basically the difference. Let's post. This is very important. As I mentioned before, Docker works on top of, let's say, the Docker engine. And between the host that is in this scenario, my machine, the Docker engine, and the containers, there's like a network interface. There should be something that communicates the both ends. So the expose is more like a document. Yeah, it's like a way to document which HTTP, well, not only HTTP, but TCP or UDP ports your container exposed. It's basically telling you, or the end user of the image, like, okay, this container used, I don't know, the 80 port, or used 3000, whatever. So this is very important. This is only for document, because at the end you can decide on runtime which port you want this container to expose. But this is to let the end user to know which TCP port is used. So the user command, by default on Docker, it will run every command on root user. But for security, or for example, there are ways to run Docker containers on a privileged mode, which will get some like pseudo powers from the local host. So it's very important to tell that this isolated container runs on a specific user, not the root one, because right now it's very hard to happen. But at the beginning of Docker, there was some ways to exploit this. So if you have your image running on root, it could happen like if one hacker gets into the containers, it could happen that this hacker gets also to the local host, and that will be a mess. But right now, I think it's, but it's better to be sure. And the CMD is also I would say like mandatory command, which basically we will tell like, okay, what will be the default command that these containers will run once we put it once we put the container running. So that's basically, in our scenario, will be basically node source/app.js. That's basically what we need for this scenario. But yeah, it's basically the way to tell the Docker container what command to run at the end. And there are many others. I'm not explaining all of those here because there are many others. So let's Dockerize our app. Okay, I would say that's pretty easy. Of course, I have the Docker file here prepared. So the thing is like, we need to create, as the Docker compose YAML file, we need to create a file called Docker file, just like this. You can see like VS Code already detected this Docker file. So at the beginning, it was telling me like there's an error. You can see like, okay, you need to specify from. This is very mandatory because otherwise the Docker file doesn't make any sense. At least you can have like a Docker file that only is a from, and that's it, and it works. But you need at least this one. So here is the Docker file that we are going to use. Sorry. So I will explain. For example, the first one is we're using Node. The syntax to use images and a specific tag is like this. We just specify here. We're just telling it like, okay, go to Docker Hub, which is a global registry. Get this Node image, and after the column we get this tag, which is like, okay, the version 11 and Alpine. What is Alpine? As I mentioned before, the idea is to have the containers lightweight as possible. So we just make it much portable. So we can go to, here's the Docker, here's the Docker Hub repository for the Node. You can see that it's an official repository because it's maintained by the Docker guys and also the Node.js guys. So here is where you can see like, okay, the different tags that this container has. So it contains many different versions. So we're using the version 11, and we're using the tag Alpine, which is, you can see here. For example, here's the standalone version. I think it goes to Ubuntu by default, but we're using Alpine. And Alpine, you can see here, is an image based on a popular Alpine Linux project. And Alpine is basically a very lightweight Linux operating system. So it basically, you can see that its size is more or less 5 megabytes. So for production environment, it's very great. And because, for example, in ECR, which is like the registry for AWS, for example, for a production application, you will have a private registry because you don't want people get your code, of course. So, for example, the model, the pay model of ECR, for example, is how much megabytes do you have or terabytes or do you have on your registry. So the most that we have this in a lower number, we will have to pay less. So that's one of the major benefits to use Alpine for production environments. But the thing is, like, as it's very lightweight, it contains like basically no cool tools. Like, for example, you cannot use makefile. For example, you need to install a dependency for that. You cannot compile C++, for example, that is needed for many dependencies on Nodejs. For example, in this scenario, we are using one dependency that needs to be compiled, which is bcrypt. Do you remember bcrypt? We are using it for hashing and encrypting all the passwords that we use. So that the dependency needs to be compiled using C++ and all this stuff and makefile. So that's one thing. So that's why after doing fetching the 11 Alpine, I'm doing this run script, which basically this APK is basically the dependency manager of Alpine. It's basically as apt get. So I think Ubuntu is basically the same, but it works on Alpine. So basically, I'm just getting or upgrading, if that's the case, G++ to compile C++, Python, and makefile. This is needed because otherwise you can make commands like this. Otherwise, it will basically fail. It will not be able to compile this. You can see here, bcrypt. This is the guy that needs to be compiled. So let's remove this application. This comment. So here we have the word dir. This is just like a, because by default it start at root directory. So it's good practice having somewhere else, but it's kind of optional, I would say. But yeah, here it basically will move to a app directory, or if not exists, it will create it. So here. So here's basically we are copying package.json and package /log-log.json, where this is a wildcard, which basically match everything that contains this structure. So here we are copying these two files, and why we're doing that instead of just doing, because you can see we can just comment this, move this. Here, basically, we're copying everything from the current directory, which is this one, to the app directory, and then we're running npm install with the option of production. So basically, this will work, and the thing is like as I mentioned before, the Docker file works by layers. Every time you run a command, it will create a new layer, and it will be like let's say a different image. So the thing is like, this is a layer, it will create a different image, then it will create this layer, and then when it goes to this part, it will start catching whatever it contains to the previous layers. So the thing is like, it's very often to occur that you only update the dependency but not the code base. That's why we use this copy different from copying everything else. Because, for example, if you let's say if you if you update your dependency somehow, everything that goes below it will run it again. It will not get cached. So the idea is to update my dependency, then install all the do the npm install again. But the thing is, like, if we just update, like, I don't know, something in the code, everything will get cached. I will only copy the code without installing the dependencies again. So that's the idea, is to speed up the build process, basically, because we can just ignore that. It will work always, but the thing is, like, it will always update the dependency even when it's not needed. So that's why we first copy the package JSON, and then we copy the rest of the application. And this flag is just to, as you can see here, we got dependencies and then dependencies. That dependency, as you can see, we only have like the lint or utilities, the shy for the testing, mocha for testing as well. This is for development, Pino, Pretty. This is for Pretty logos, whatever. The thing is that we don't need this one a real production application. It's only for testing or development. So with this flag, we only install the really needed dependencies. That's why the separation of this. So it's very cool. So here the environment we're setting on production because we're trying to build a production-ready container. And then, as I mentioned before, it's a security, let's say a security-wise way to go is like always change your user to something else that is not root. By default, it will run root, but basically we're just giving permission to everything that is on the app directory to the node and group node, which is by default installed on is created on this image. That's why I'm not creating the user. I'm just telling it use it. But otherwise, I will need to run something like user add whatever. But it's not needed because no user is already there. So we give permission to the user, then we use it, and then we basically run the application. And yeah, that's it. We use the node CRS/app. And there's one important thing. Since we are doing this copy, whatever, like everything we have here to the application, it will basically copy as well the node modes, and we don't want that. So basically, as we have a git ignore, we also have a docker ignore file, because it's better to ignore those kind of files because we want to update. And in this specific scenario, that Bybgrip is being built on side of the container, we want to be built in the current environment because the build process could be different on Mac OS, and Docker is always on Linux. So it's important to build it the correct way because otherwise it could crash. So here we create a .docker ignore file. Yeah, it works like a git ignore. We can just, I would say, like copy the same. Yeah, I think it's pretty much okay. Yeah, we can copy the same stuff because we want to ignore, for example, node modules. We don't want to move our .m file, and yeah, we can just ignore this. This is very important. And then, how do we build the application? Because everything looks great, but we need to actually build it. And it's we use Docker build, and then the dot. Dot means like, okay, the Docker build will look for a Docker file. So we're telling him, okay, look it on the current directory. So we run this. I will start. As you can see, you have different steps, 1 of 10, 2 of 10, and it matches every layer that we have here. So the first one is just, okay, get the node Alpine. I already have it locally, that's why it's not downloading anything, I already have it. Then installing the dependency here, making the work directory, copying the package JSONs to the app directory, installing. Here you will notice here is starting to compile the Bybgrip. So here you can see it fails because it's telling me, okay, I don't have like a pre-built binary, so I need to build it by myself. So it started to build it. So it is it finished Then we copy the rest of our project. We set up the environment file, the permission, we use node, and then we specify the command, and that's it. So we have our Docker container. So the thing is like, well, that will be part of the homework to be able to use or actually create, because right now we created a production-ready container which contains all the code ready to be used. But the thing is like, since we're starting to use Docker, it's very great to also start using it for development. So we can create a new Docker file and put the API just here, like, I don't know, API instead of image, we will specify build, whatever. So that will be part of the homework. Right now I'm just showing how to use it like on production ready, but there should be like some consideration to be made in order to make it like development ready. For example, to copy all the code is not good, because the idea is like once you're running a Docker for development purpose, it's like, okay, I want to, once I change my code, I want to be replicated right away. I don't want to build again the Docker, because that will be very annoying. So for example, this is just a hint, this will be necessary at all, but there's a way to do it. I can explain a bit later. So this is a production-ready container. So the things like we're using Heroku. Heroku provides a way to use containers. On the documentation, we go to deployment. You can see that it goes to deploying with Git that we already used, and then we deploy it with Docker. And then we go to here. And as I mentioned, it contains its own registry, which is private, and you use to deploy all the images there, and it will basically run. So the thing is like, in order to do this, we need to, for example, make the build step on the Travis, and then push that Docker to the Docker to the Heroku registry. But recently, I just find out, and you just posted very like was it yesterday? You can see here last day, 13th of November. It's like now they provide this amazing file, which is like the proc file. It's called Heroku YAML file, and with this is very great because you can still use Git to deploy your changes, and the build will occur on their side. You don't care about this, because what I did right now, this Docker build stuff, wasn't necessary because I don't need to have a build image right now. I just need to specify this file now. This is only with Heroku. With other providers, probably you actually need to push the container, the image. So yeah. So the Heroku YAML file is very easy to set up. We can just copy this, I think so, yeah. So yeah, let's create it. Heroku YAML. So here, basically what we are telling it like is pretty much similar as the proc file. We have a web and then we have a release, right? So for example, we need to tell it, okay, I want to build one Docker. This is for the web dyno. This is a HTTP API. So we're going to use Docker file. That's great. That's the name of my file, because it could happen like it's another name, but that's the convention to name it like this. And then the run is basically the same as this, but this is optional. Why? Because the run command is already specified here. We don't need to. We can just make this. Oh. We can make this. It will be okay. It will work. But the thing is, like, it's already specified on the Docker. So this is complete optional. And the things like we need to. So far on the Docker container, okay, this is production ready, but there's one important step missing, which is the migration. So we need to specify the migration as well as we did here. So that's also possible. We go down here. So here, we grab this step. So there are many steps, but to make it simple, let's just grab this one. You can look at it. It's amazing. I would say it's pretty great to have this support. So here we specify the command, the release, the command that we want to run. So basically we just copy and paste this because it's exactly what we want. And the image is not a worker. This is because on the example there we're using workers and stuff, but that's not our case. We want to use the same web image that we have built here. And yeah, I think that's pretty much it. But there's one step to make, which is, do you remember the stacks, which are basically the let's say like a combination of the operating system and the runtime, which is in this scenario is Node.js. So we need to tell now to Heroku that we're not going to deploy a raw code of Node.js and it will run on a Node.js runtime. We need to tell it like we are now providing a Docker environment. That's all we need. We don't need you to install Node.js. We just need to have Docker running, and that's it. So we need to change the stack here. I think if we stack, we can see, yeah, you can see like the Node.js Nights Heroku has this for available stack, and we're using Heroku 18, which is a Ubuntu 18 version. But the thing is that we need to use this stack, which is the container. So we copy the comment, and here we're telling it like, okay, it's ready. The next release will be a container, so it will ignore completely the proc file. This is useless right now. I will keep it just for the example. But now instead of reading this proc file, we'll read for the Heroku, and you will start. Okay, it's a Docker web. Dino, I will look for this Docker file, it finds it, and you start all the build. And then before releasing, you will run the migration. And that's it. So I think, yeah. So if we commit this, because we have our Travis ready to set up, we don't have to do anything with Travis, because we need Docker, but that's already set up. And yeah, as you can see with this Heroku YAML file, everything works with Git. So because otherwise, we say like before this support, we will have to change this a lot. I mean, like for example, okay, we stop here, we run our infrastructure with the migration, we do the test, and after success, I will say, or before that, yeah, here we will have to put this, something like that, like this. And then we'll need like the credential for the Heroku registry, push everything, which is some command like this. And yeah, but the thing is that we don't need it. That's pretty great. So let's add everything here. Init local deployments. I think so. Yeah. Okay. So yeah, it should start right away. We go to our Travis, branches, it trigger a new build, and we can go to the Heroku settings. We should be able to see like, yeah, the stack container will replace Heroku 18 in the next deploy. So it's expecting for a Docker ready build. So that's great. Our environments variables are, we can just leave it as it. It will just inject the variables when the Docker container starts. So that's great. And yeah, that's. That should be like just like that. So we go to now you will notice that when it started pushing the changes, you will see the logs of the actual as you saw here, like all these, which are for the layers, like step 3, step 4. We will see exactly the same because it's building the stuff. But the thing is, like, we're not building on the Travis, we're building on the Heroku side, which great. So yeah, it was cooling, sleepy 5 seconds. Migrating, everything okay. Loading coverage. Okay, so here it goes. So it started to fetch everything, and you can see it started a Docker build, exactly as we did in the local machine. Exactly the same steps, and that's the magic of Docker. We are completely sure it's the same steps. It will occur the same way because that's what Docker about, like to keep everything like in the same environment. So yeah, it will start. Here is compiling the bytecrypt. Here you can see that the pre-built binaries are not found. That's why it falls back to start building the stuff. And yeah, it started doing a lot of stuff here. And actually here we can see like the build is in progress. It's happening everything parallel. Here is pushing the, as you can see the registry endpoint is actually registered to the header root .com / the name of an application and the / release. So we can make it on the old way of Docker, which is I need to log to this registry, and then I build the container, the image, and then I push the image to this registry. But this basically is happening here. That is very weird. It needs to log the logging unit, but and they are in the same environment. Okay. Of course, Docker, the things like it could take more time to deploy, but yeah, I think the benefits are more important. So yeah, it finished. Yeah. So yeah, here we have our application, which is running in Docker. Settings. Stays in this way. Should say logging container. But yeah, we can check here. This is weird. Probably it takes time to. No, actually just deploy. Oh, there was an error. Okay, look, this happened. Look, it failed on the build of the Docker container, and then it fall back to the old way to deploy. But what happened? Say anything about it? Okay, let me check. Okay, it's pretty interesting. Probably on beta. This, let me check again. I will just restart the build. But meanwhile this happens, I will continue with the presentation. But that's very weird. Okay, so yeah, I'm very good to use it. That's where it's done right now. So let's wrap up. So tonight we saw how the difference between deployments on-premise data centers and cloud. Of course, the the way to go is cloud, or otherwise you have a very interesting reason. We have different deployment for cloud, infrastructure as a service, platform as a service, software as a service, and serverless. We use Heroku, the different like the architecture, like the dynos, the stacks, the add-ons. It can be like databases, catch, logs. Then we have explained about like the continuous delivery. That this the way I believe is the correct way. You could probably find different way that all different authors explain this. But yeah, continuous delivery. Well, if you have a continuous delivery pipeline, it means that you have both continuous integration and continuous deployment. Then we attach Docker to all of this, and then we use Heroku and Docker for all the deployment. So yeah, that's basically what we have done tonight. And the homework, as I mentioned before, there are two homework. One is to make a Docker file only for development. It's a totally different Docker file because that's very often to happen in a project. Like you have like a local development. You have like it could happen as well. Like you have a testing ready Docker file. Like instead of running the application, it runs in this scenario Mocha, and just a Docker container that just is your testing. It could happen as well. So the idea is to have this development only Docker file and attach it to the Docker Compose, so you can use run infra, npm run infra, and you have not only your database but the application running and everything. And the other stuff is like to add a code coverage tool to the continuous delivery pipeline. As you can see here, no, not here, in the Travis YAML file, we have this after success. I just leave it the hint of the comment. So you can just put code coverage and upload it somewhere. So the idea with this is like for example, this service integrates very well with GitHub, and you can see on pull requests or even on some automatic comments, or you can even push the code coverage to a Slack channel, and you can continuously see how the coverage is working on your code. So as Travis CodeCov, I would recommend to use it. It's free for public repositories. So yeah, that's the homework. Yeah, that's it. Okay, now let me check again.
On time.
Yeah, but it's the same. Well, by the way, questions? Any question, guys? I will update the repository probably tomorrow. Put the lecture and the readme for the lecture. So yeah.